Have you ever stopped and wondered what's really going on inside that machine you use every single day? Well, today, we're going to pull back the curtain and demystify the physical parts of a computer, otherwise known as its hardware. So let's just start with this question. What are the actual building blocks of the very device you're watching this on? I mean, we use these things constantly, but what really truly makes them tick? Let's dive in and find out. Okay, first things first, let's start with the most basic concept of all. What exactly is hardware? It's actually pretty simple. Hardware is everything about a computer that you can physically touch. If you can see it, if you can pick it up, it's hardware. We're talking about your screen, your keyboard, and yeah, all those complicated-looking parts tucked away inside the case. Here's a really great way to think about it. The hardware is the computer's body, all the physical stuff. The software, on the other hand, that's the brain. It's the set of instructions and programs that tells the body what to do. And here's the key. You need both. A body with no brain can't do anything, and a brain with no body is just, well, it's just thoughts with no way to act. All right, so now that we've got a handle on what hardware is, let's pop the hood and take a look inside the engine room. This is where the real magic happens. Or, the processing. The first thing you've got to know about is the CPU, the Central Processing Unit. Honestly, just think of it as the master craftsman of this whole operation. It's the brain of the brain, the core worker that gets all the instructions and does billions of calculations every single second to make them happen. It's doing the real heavy lifting. So, if the CPU is our craftsman, where does it do all this work? Well, that brings us to RAM, which stands for Random Access Memory. RAM is like the craftsman's workbench. It's a super fast but temporary space for all the data and programs the CPU is working on right now. The more RAM you have, the bigger your workbench is, which means you can work on more things at once. This is exactly why more RAM is so important for things like gaming or having 50 browser tabs open without your computer grinding to a halt. Okay, so what happens when our craftsman is done with a project on the workbench? It can't just stay there forever. It needs a permanent home. And that is the job of your storage. Think of it as the workshop's giant filing cabinet. This is where everything, your photos, your documents, your games, gets stored for the long haul, even when the power's off. Now, there's a big difference here. Newer computers use something called a solid-state drive, or SSD. It's like a super fast digital filing cabinet. Older computers use a spinning hard drive. That SSD, that's the reason a modern computer can boot up in just a few seconds. It's a total game changer. So we've got our master craftsman, the workbench, the filing cabinet, but how do they all talk to each other? Well, every single one of them is plugged into the motherboard. You can think of the motherboard as the factory floor itself. It's this massive circuit board that connects absolutely everything, the CPU, the RAM, the storage, and lets them all communicate and work together as a team. Okay, we've explored the engine room deep inside the machine. Now, let's zoom back out and look at how we, the users, actually give it orders. This is all about the external hardware, the stuff we use every single day. And I'm pretty sure you're familiar with these guys. The keyboard and mouse, that's how you give commands. The monitor and speakers, that's how the computer gives you feedback. All of these things are called peripherals, basically because they're on the periphery, or the outside, of the main computer box. And this right here shows the entire communication loop in action. It's beautiful. First, you provide input. You type something, you click your mouse. That signal zips over to the internal parts for processing by that master craftsman, the CPU. Then the result is sent right back to you as output on your screen or through your speakers. Input, process, output. And this loop, it's happening thousands, even millions of times a second. So let's put all the pieces of this puzzle together. We've seen the internal engine and we've seen the external controls. How do they actually become one single, seamless system? This is a great way to see it all at a glance. You've basically got two families of hardware, the internal crew and the external crew. This shows you where they live, inside or outside the case, and what their main job is. You've got the thinking and short-term memory happening inside, and the communicating and interacting happening on the outside. It's a perfect partnership. Okay, so we've looked at all these parts and pieces, but why does any of this really matter to you? What's the real-world takeaway? I mean, why should you care about the difference between a CPU and RAM? It matters because this knowledge is power. Seriously, the next time you're looking to buy a new computer, you'll actually understand what it means to get more RAM for multitasking or a faster SSD for quicker load times. And when your computer starts acting sluggish, you might have a good idea why. It lets you make smarter choices about the tools you rely on every single day. And this is what I find absolutely fascinating. The components we just talked about, with their billions of microscopic parts and mind-boggling speeds,
This stuff was pure science fiction just a couple of decades ago. It just makes you look at this incredible device in front of you and wonder, if this is what we have today, what on earth will the hardware of tomorrow look like? What comes next?